Everyone feels been coming at ya. One of the downsides to render streaming is that typically a server can really only host up to 3 or 4 users without running into GPU bottlenecks. And as a result, if you're really looking to build out multiplayer scalable solutions, you need to have multiple different render streams that are connecting to clients. And to do that, you need to connect all of these different servers together through just standard multiplayer. So in this video, I want to go over exactly that and show you how you can integrate multiplayer into a render streaming solution, which enables you to have insane low latency between all of your different edge rendering servers because they could all live within the same data center and same network. And I think that opens up the door to some incredible opportunities when it comes to creating games that don't necessarily require having the insane interpolation extrapolations that we typically see. In this video, I'm going to be specifically looking at Edge Multiplay, which is an open source project that we've looked at in the past on the channel. And one of the advantages here is, unlike other managed multiplayer solutions, this is a self-hosted solution, which means that you can exactly put the same multiplayer backend into that same server with render streaming. And that enables just a lot of flexibility in terms of optimally designing that backend for render streaming. So have Unity 2020 open up here, and just to save some time as far as the implementation goes, I've gone ahead and downloaded all the open source files that we need. So let's specifically quickly just take a look at that. First, we have the FuseVR VR render streaming package that you can go ahead and import into your project. So that we're looking at right now is 0.6. With Mobile Edge and Edge Multiplay, you're going to go ahead and pull in that latest version as well. And there's documentation on how to get that set up over on YouTube that you can take a look at. And finally, because we're going to be taking a look at the apartment scene, I've gone ahead and pulled in the relevant VRTK packages so that you can have that already hooked up and ready to go. Last but not least here, we've gone ahead and pulled in Edge Multiplay as well as the apartment sample, which again, you can follow all of those relevant videos to get all of this base project set up. And Edge Multiplay can be downloaded from Mobile Edge, and if you go to examples, Edge Multiplay, that's where you'd find that. And with the setup window, these are the credentials that you're going to be wanting to use. So that's just the high level setup here. And we have the apartment scene that I have gone ahead and set up, and that has just been the base that has been included with VR render streaming. So looking specifically at this, we have our VR broadcaster, which just as before with last time, it was set up to support up to 4 connections of players that could interact with this apartment scene. So I'm going to actually swap that back down to 1 so that we can highlight how you can set up multiplayer in this scenario. So here we have just our VR streaming player prefab that is just responsible for the avatar. And then let's first actually go ahead and we'll need to just set up the multiplayer here. So for that, I'm just going to go ahead, create an empty, and we'll call this the Edge Manager. So the Edge Manager is responsible for actually setting up the multiplayer in our case. So let me go ahead and pull that in. For that, we need to create spawnable prefabs and spawn locations. For the purposes of our spawn locations, we're just going to keep them to 0, 0, and we're going to be supporting 2 players in this case. And then we just need to create a prefab that we want to go ahead and instantiate here. So let me go ahead and do that. You can see here it requires the networked player, or what you can do is actually create your own networked player as a player manager. There's a template that I've already gone ahead and created for us under Create Edge Multiplay Player Manager. So why don't I go ahead and open that up? And while that's opening, let me quickly switch back to Unity. And then we'll want to create a player prefab that is responsible for being that network player. So let me go ahead and do that by creating let's just create a sphere for now. Actually, what would be better, I have the prefab here, which has that avatar. So I'm going to be basically deleting most of this stuff that's located in here. And then let's just go ahead and get the sphere and cube. That's it. Drag that up, and then we can delete the rest. So let's go ahead and delete these. And so we just have a very simple avatar that we can use to represent the head of this specific player. Let me just call this multiplayer. And here I'm gonna go ahead and add in our player manager. And let me also add in an Edge Multiplay observer. And for the observer, I'm going to just create something to listen to, just one element, and then we're going to assign our current transform to sync across all of the different instances of render streaming. And last but not least, let's just go ahead to sync position and rotation. As I mentioned in the intro, we actually don't really need to sync position rotation or at least interpolate those. You can if you want, but it's not really required because we're going to have relatively low latency in this setup. So that's our avatar. I'm going to go ahead and create a folder. Let me just call it prefabs. And we'll go ahead and drag our new avatar prefab in here and assign that as both the elements here. So going back into Visual Studio Code, with your template, you pretty much get everything up to here. And in our specific case, I've just gone ahead and added an update method that's literally just responsible for capturing the render streaming position data and rotation data and applying it onto our player manager. So what we're doing is just checking, is this player the local player for our instance? If so, we want to go ahead and copy the render streaming data for position and rotation and apply it here. So that is basically what happens. So since we only have one client stream, I'm just going to find that in update, assign that to the main player. We actually don't need this debug. And then just every frame, just apply the position and rotation to the player manager. As you can see here, because this is on the player manager, it's going to go ahead and apply that onto the transform. Thanks to the Edge Multiplay observer, we're syncing the position and rotation for our player across all the render streaming instances. In this case, we've only gone ahead and assigned it such that there are going to be two players that are possible to be connected together. If you want to create more than that, you can easily do so by just adding in more spawnable prefabs, which represents the number of players. And that's really all there is to it as far as setting this up from a networking standpoint. We have our VR render streaming and we have the Edge Manager already. So what all we need to do now is, oh, there's one more thing I almost forgot to mention, which is you need to add a game manager. The game manager is just kind of a default that you can use, just like the player manager. It's under Edge Multiplay game manager. Just make sure you have that, which is responsible for just handling the default states that happen with Edge Multiplay. Okay, so what I'll go ahead and do now is just head over to our build settings, and in this specific case, I'm just going to create a Windows build, and let's go ahead and save that. So here we're going to create a build, and then we're going to also stream from the editor. So we'll have two different versions that are going on here. And let me pull this up. We have two instances of our render streaming going on. If we wanted, we could actually set up a game ID so that you guarantee connect to different instances, but you can also connect to the same ones, and it's really not that big of a deal. Once that's finished building, you'll have your app over here. What I'm going to go ahead and first do is let's start this up in Unity. So give that a second. Once that does, you'll see that set up here. And let me go ahead and open up client 1. Get that connected. Just pull this around. You can see here, there's our avatar representation. And next, I'm going to go ahead and find our folder. Let me go ahead and start the second stream here. You won't see anything just because nothing gets rendered out to the display. You can already see within Unity, both our players here have connected. And in fact, you can actually see that player 1 has been synced up. There is an offset, which I'll explain in just a second, but let me first go ahead and render stream connection here. You can actually see MetaMask popping up as well. And this is client 2. You can see here is connected. And we can go ahead and rotate. Now, the thing to note here is this is actually not going into Unity. This is actually headed into our build instance here. And similarly here, I can go ahead and move myself around. Why don't I go ahead, move here. And actually, you can see it started clipping, but that's fine. Point of the matter is just to very quickly highlight here what's going on. Now, the reason for that slight offset is actually because on our render streaming, if I go ahead and take a look at what I'm copying, so I'm specifically copying this WebXR streamer here. So these are the exact same data points that you can see get copied onto our local player right here. However, there's actually an additional 1.6 offset. The reason for this specific offset in this case is due to the floor mapping. And so as a result, just to make sure that you are floor, that is what's happening here. And that's not captured, of course, on what we're copying. If we really wanted to be specific, we could go ahead and update our head tracking and make sure that we're getting that instead of the VR input manager transform. But just to save myself a little bit of coding, I went ahead and just picked up the actual just overall positional data. But in similar fashion, you could then start using this for, say, VR. You could start using this for various different synchronization points that you would want to actually hit. But this is just mainly to show the premise, right? We have our Edge Multiplay observer that is syncing transform data that we have gone ahead and copied from render streaming, and you have a very nice back and forth in that capacity to actually highlight what's going on. So as you can see, not a ton of code that's necessary to actually get this setup running. And the nice part here, as I mentioned before, is that because the Edge Multiplay server is open source, you have the ability to run this within any data center that is near your render streaming servers. And that's just significant because of the fact that we can actually control for latency in this scenario. And so it just kind of makes sense to have Edge Multiplay right next to the render streaming servers, and Edge Multiplay allows you to do that. So hopefully this quick setup was helpful to just show you kind of what you can start to do. If you do have questions, definitely let me know down in the comments below. Of course, if you have other multiplayer solutions you'd want me to take a look at, also happy to do so as well. But I think that'll wrap it up for now. And again, thanks so much for watching, and I'll catch you in the next one. This has been FuseMan, and I'm signing out.